Hello, and once again welcome back to the cellar. Today this is a little bit of a follow-up to the board controller video. I'll stick a link in the corner somewhere, looking at the problem I had with the TLC5947 LED controller. Yeah, I've nailed down what the problem is. It's a complete boo-boo on my part, really. Yeah, let's go down into the cellar and have a look at this. Yeah, welcome to Leopard Street. Right, previous video, this TLC5947 LED controller. As you may have seen, I was having some fun and games with trying to get this to work. I've got a few of these on the layout. They're not terribly reliable. I've found the problem, and it's a gun foot aim fire moment. This is a complete module. Let's just put this to one side for a sec and bring in this, which is the data sheet, and this is quite useful. So it says up here, you can supply it with 3 volt to 5.5. Now I saw that and I thought, oh well, it'll work with the 3.3 volt circuit. Brilliant. And you come in, it tells you all the different versions you can have. I mean, we've got this version of it here, what the different pins do. And then you come to this bit, and this is the gun foot aim fire moment. So VCC 3 volt to 5.5 volt. Okay, I'm feeding it 3.3 volt. Then you look at these two lines here. Now, if we go back to the board, I'm actually not feeding this 3.3 volts. I'm feeding this 12 volts on this line here. And when I was testing it, I'm feeding it 5 volts. But there's this on the board as well. And what this is a voltage converter. And this is taking the input voltage and lowering it to 5 volts for the chip. It's like, So this is why you can run this on up to 30 volts. You wouldn't in practice, you need a heatsink, but you run it on, say, 12 volts quite easily. It puts that voltage on these output pins. The board takes the current goes from that into the cathode, which then goes into this, and it drains away, and that's how it works. This is working on 5 volts. So this is where this here becomes a problem. So that is 3.6 volts, and that is 1.5. So if I find a bit of blank paper on the back of this, what we've got is 5 volt up to there, and then we've got 1.5 and 3.6, and these come along here like this, nice and happily. And basically, if we're in this area, it'll see it as logic high. If we're in this area, it'll see it as logic low. And if we're in this area, who knows? Undefined behavior. That'll vary chip by chip. Now the problem I've got is I've been feeding it 0 volts as logic low, which works brilliantly, and 3.3 as logic high. This explains why it works sometimes on some boards, and a very, very slight variation, just a slight change in the resistance of a bit of wire, all of a sudden it doesn't work. There's a problem. Now, while this chip will work with 3.3 volts, because of the way these boards are built, this regulator means I can't use it that way. This is a 5 volt design board. It actually quite clearly says on the back, V plus 5 volts to 24 volts, which is okay, because that's basically what this regulator's rated around. But these logic lines, I'm feeding on 3.3 volts, and that's why it's not working. So, data sheets, always a good idea. Always check the data sheet. Sometimes you find things that are mentioned online are wrong. So, what are we going to do about it? Yeah, so just to summarise that, this is what we've got. ESP32, this runs on 3.3 volt internally, 5 volt supply feeds into that, it's got its own little regulator.
TLC5947, I'm feeding it on 12 volt, it runs on 5 volts internally with its little regulator, but all the lines going between the two are 3.3 volt logic, because they all are driven by the ESP32. And as you can see, again, I've redrawn the little graph on the side, and we can see why it doesn't work. It's smacking the undefined behavior bit. So what are we doing about this then? Well, what we need is this. We need to stick in a voltage level shifter of some description that can turn the 3.3 volt logic into 5 volt logic. So what we have is a little box that sits in the middle and works in both directions and swaps the voltage levels around. So the TLC5947 sees the 5 volt circuit that it actually wants. So let's have a look and see how that works then.
Well, here is a test board. This is the other sort of ESP32 I've got. I'm using this instead of the actual board F board because I've currently got that screwed to a piece of plywood under the layout because it didn't need to have this functionality sorted out. So yeah, I'll sort that one out later. The difference is this one's got a screen built in and it's got a blue LED that goes absolutely haywire because I've told it it's the other sort of board and it's not. So here's my lighting control board. This one's got a capacitor fitted, the other one hasn't. It will have before it's used. And then we have this hiding under all the wires down here. This is a voltage level shifter. So what this does is it says, put your low voltage signals in on one side. In this case, this side here is 3.3 volts. Put a high voltage signal on this side, in this case 5 volts, and this will convert all of these signals into 5 volts, which works on there. Here I've got a little test LED, and if this doesn't work, I'm going to cry, but it should work because it's connected to the Wi-Fi. There we are, light comes on. Light goes off. I'm happy with that. Fairly simple. Yeah, so what I've now done, I've got an order placed for more of these chips. I think I've just paid about £2 for 10 of them. They'll be here in a week or so, at which point what I need to do is find a way of wiring these into the layout to talk to these boards. This is, I think it's an I2C level shifter, but this one is bidirectional and it will handle 4 data lines, which is perfect because I've got the 4 data lines here, the data, the clock, a latch line and an output enable line. And all of a sudden, this is working perfectly. Very, very happy with that. I've not put the output pull-up resistor on this at the moment, so that functionality doesn't work, but that doesn't matter, that's on the other boards. This was purely to make sure the data connection worked. So, in about a week or two, there will be another video which will show how I've turned one of these. I'm thinking what I'm going to do is basically modify a wiring harness, because I can add the 5 volt high voltage at this end in this spare pin, which is actually what that's for. That can be provided as the high voltage level. I've got a low voltage level I can grab off it as well somewhere. I can just create some sort of wiring harness that I can use on the boards, and away we go. And that should do it. And then I should be able to get the lighting on the layout working reliably, and there's a few things I want to do with that, so I need that working. But I will be back in the next video. Thank you very much for watching.
Yeah, and just to confirm on that, the order is in. I'm still waiting on delivery, but never mind. If you found this helpful, likes, shares, subscriptions, upticks, comments, all that sort of stuff, all more than welcome. Any questions, let me know. I will at some point do a deep dive into how these boards actually work and what you can do with them. They are quite interesting. I will catch you all in the next one. Thank you very much. Goodbye.